In this video, I'm going to show you how to get started with Langchain and Pinecone in Node.js. We'll set up an application where it will run through a directory of documents like we have here, and we'll take those documents, we'll break those documents up, we'll query the OpenAI embeddings API. Once that's returned, we'll upload those embeddings as vectors into our database. Then finally, once they're in our database, we'll go ahead, query the database, get the top results, and then pass it to an LLM for an answer. So we'll be able to ask a question and then get a result based on what we have uploaded in our database and what documents we have used. So all that we'll need to get started with this are our API keys. We're not going to be setting up anything in the GUI on Pinecone. We're going to do everything from scratch in Node.js. So the way that I have this structured is we have 4 main files that we're going to be working out of. I have them numbered in both the order that we're going to be using them and going through them in this video, but also the order that they're going to be used in the final state of the application. So we have our entry point, our main.js. This is going to be our actual Node.js file that we run. And then from there, we're going to have some files that we've exported into our main.js. So one to create our index, one to update our Pinecone instance with our vectors and embed. And then we're going to query Pinecone and query the GPT model to get a result. So the first thing that I'm going to have you do off the bat is we're going to go npm init-y. So that will get our project all set up to install some dependencies. So once you've done that, you should have a package JSON on the left here in your VS Code or code editor. Then once we have that set up, go ahead and make these 4 files here. So we're going to have a main, create Pinecone, etc. So once you have those set up, go ahead and create a .env. So in our .env, once you have that set up, you can sort of go split screen if you'd like, or just hop back and forth. We're going to go over to the OpenAI API page. So you can go platform.openai.com/account/API keys, create a new key, and then once you have that key, just paste it in here. So one thing to note with the OpenAI API, you do have some free credits where you don't need to tie in a credit card off the bat. So if you want to try this and you don't want to integrate your credit card into their system, you don't need to worry about that. You should have more than enough credits to get off the ground and running. Now, similar with Pinecone, you do get a free index. So there are some limitations with the free account, but you will be able to do everything that I'm showing you without tying in a credit card as well. So once you've set up the OpenAI API key in your .env, make an account on Pinecone. If you haven't already, then just go to the API key section. So here we're going to need both the environment and the value of the API key. So the environment goes just as you see here, and then the API key goes here. So once we have that, I'm just going to hop back to our main.js with our instructions here. We're going to install a handful of things. So while I do that, I actually want to pull up the package JSON. So in the package JSON, we have 4 dependencies. We have the Pinecone dependency, .env, Langchain, and PDF parse. So I just want to touch on PDF parse for a moment. So if you're using PDFs, so you'll see in this example, I'm not using PDFs, but by the end of this video, you'll be able to incorporate PDFs to read and store if you'd like. But if you'd like to include other documents like docx or EPUB, there's going to be some other dependencies that you're going to have to reach for. So I'll cover that in just a moment. But just one thing to note, you may, depending on what you're trying to build, need to install some other things as well. So I also want to touch on the version. So I'm running Node version 19. And if you're within this range of between 17 and under 20, let's say, you should be good to get this all set up. So if you npm I all of these things here, pinecone.env, Langchain, PDF parse, you should be good to go. So just make sure you're not running like Node version 14 or something where a lot of the dependencies might fall out of date and this might not work. So you can check your Node version by just typing in node-v in the terminal, and you'll see if you fall within that criteria. So once we have that all set up and installed, we've obtained our API keys, we've put them in the .env. Make sure you save that .env just so we don't forget later on when we go to run. And like I noted earlier is, so for the file loaders, so we're going to have to specify them one by one, and they could use different dependencies like I mentioned. So if you want to see what kind of file loaders that there are, you can just head over to this link and take a look. So CSV, docx, etc. So if you go to docx, you'll see you'll need this dependency, and there's others for particular file loaders. So EPUB, you'll need these two dependencies and whatnot. So I'll touch on this again. You'll need to import those and install them if you need them. And then we'll reference them in the loader in just a moment here where I'll show you. So the first thing that we're going to do is we're going to require a handful of things. So we're going to require the Pinecone client itself. So this is going to be how we actually create the index from the backend, and then also update and query. So it's pretty integral to what we're doing here is the Pinecone dependency. Now the directory loader, this is the way that we can actually read everything that's within this directory. And then for each file type, you'll have to specify them here. So if you had the EPUB loader, just import the EPUB loader from the proper spot and whatnot. So we're going to require the .env. That's sort of self-explanatory. That's how we reach into our .env and read the API keys that we'll need to interact with both OpenAI and Pinecone rather. So then here we're going to import the files that we're going to be building out after this one. So we have our create Pinecone index, the update Pinecone, and query Pinecone, and query GPT. So we're going to initialize our .env, and then from there, we're going to initialize our loader. So this is where we'll set up all the different file paths or file types and paths that we're going to be setting up. So if you had EPUB, you could just add a new line here, EPUB, make sure you have the loader and installed and whatnot, and then just, new EPUB loader and whatnot. Then from there, we're going to actually call this, and it will return an array of all the documents with some metadata. So from there, we're going to set up some variables for how we're actually going to interact with this. So I have a couple of documents here. So I have Romeo and Juliet and The Great Gatsby. So you can go to, if you just Google the Gutenberg project, there's a handful of books that you can just grab and use if you need something as an example. Otherwise, this should work with any other text files or other file types if you include the loaders that you need. So the index name, that's going to be the actual Pinecone index. So if you've made one already, you can go ahead and put that within this line here. Otherwise, once we call this for the first time, we'll just initialize it with the name that we pass here. So the vector dimension, so since we're using the OpenAI embeddings model and endpoint, this is the criteria that's returned from their embeddings endpoint. So if you're using a different one or want to use a different one, just note you will need to set up the proper vector dimension for the database. So the next thing that we're going to do is we're going to initialize our Pinecone client and pass in our API key and the environment. So those were those things that we just reached for in the GUI for Pinecone. So once we've done that, we're going to go ahead and run our main asynchronous function. So in the asynchronous function, we're going to check if Pinecone exists, and then we're going to create it if necessary. So the first time around, that's going to be where it actually creates it. Otherwise, it's just essentially going to fall in the other condition of this file here, and then just skip on to the next function. Then next in this one, we're going to actually update our Pinecone. So, and you see within all of these, I'll just pull them all up here. The one thing in common, we're going to be passing in our client into all of them, and then also our index name. But in each of them, we have some unique things that we're going to be passing in. So for the first one, we're going to pass in our vector dimension. We won't need it in any of these. Our second one, we're going to be passing in the docs. That's going to be where we loop through the docs, break them up into chunks, embed them, then store them as vectors. And then finally, when we query them, we're going to pass in the question that we need. So in the create Pinecone index, you'll see how we're sort of going to structure all these files. So we're going to export const create Pinecone index, and then we're going to pass in the parameters that we need for it. So first we're going to see if the index exists. So we can do that with this client list index. And then if it doesn't exist, that's going to be where we actually go ahead and create the index. So this will run the first time. And once it's run, it will just skip to its the else condition. So one thing to note with this as well is I do have this await new promise set resolve to 60 seconds. So you could potentially remove this. So it could take a bit longer. I've sort of noticed it takes about a minute or so to set up that initial index. And once it's set up, so say you run it and you run into an error, just run it again once it's actually initialized. So you can see it in the GUI once it's set up and whatnot. But this will just sort of, you could bump this up if you wanted. So once we have that, once it's all set up and running, we can go ahead and log it for when we're running through either updating or querying. All right, next we're going to be setting up the update Pinecone function. So this is going to be the most involved function that we're writing in terms of the logic that we're going to be writing ourselves. So the first thing that we're going to do is we're going to import a couple required modules. So we're going to import the OpenAI embeddings module as well as the recursive character text splitter. So the OpenAI embeddings endpoint, so we're going to use text ADA embeddings 2 to actually create embeddings of the text chunks, and then to create those text chunks, we're going to use this recursive character text splitter. So similar to our last function, we're going to have that same structure, export const update Pinecone. And then we're going to be logging out an awful lot here. And the reason for that is hopefully to A, have you understand what's going on here, and then B, if there's any errors that come up, you'll be able to hopefully quickly go in and debug or reference the area where an issue is coming up. So we're going to retrieve the Pinecone index. So we'll do so by calling the .index method and passing in the index name. And then from there, we're going to just log out the index that we've retrieved. So in this, we're going to create a for loop because the docs that we're passing within the update Pinecone function is an array. So we're going to run through all the different docs one by one. So, and part of the reason why we have a for loop, we don't have like a fancy ES6, for each or something like that, is we want to be able to reference it within the context of the asynchronous function. So you can do that. You can await by using a for loop in JavaScript like this, essentially. So, as much as I love to use something like for each, that's sort of why we have it set up the way that we do. So once we have that, we're going to cache a couple variables that we're just going to use in a second here, and then we're also going to log out the file name. So here we're going to create the instance of our character splitter. So there's a bit of a debate on the optimal chunk size. So, some people might say 200 is good because when it scans through, it will give you like, a range within like, say like a sentence or two or within that realm. If you do a chunk size of 1,000, that's the one that I've sort of gotten used to and comfortable with. Now, if you push the limits and really go to, how many characters it can handle, it might not work as well because you're essentially having it go through these big blocks of text, and then you could potentially run into token limits when or if you want to pass it to an LLM. So you can play around with that. I'm going to use 1,000 in this example, but just know there's sort of an interesting piece there you can look into if you like to play around with. So then we'll log out. We're splitting it in chunks, and then we're going to simply pass in our text. So our text is going to be the page content from the docs object of each of them, and then this will break it up into chunks. So once it's broken out into chunks, we'll log out how many chunks that we have that we're dealing with. That will give us a sense on how long it will take and whatnot, and just it's sort of useful information to have. So once we've done that, we're going to actually embed the documents. So I'm going to remove some new lines here, and then we're just going to go through one by one and embed all of them. Then we'll log out when they're done embedding, and then just to confirm, we'll show we have the length of the embedding. So there should be continuity between these numbers. Then finally, we're going to create a batch of 100 vectors that we're going to send to Pinecone. Now, the reason we have 100 is that's what Pinecone specifies as the optimal number to upload. Just as an aside, so if I went to upload the Great Gatsby and embed all that, I'd run into an issue where it's above that 2 megabyte threshold where it won't query and upsert that into the database. So you need to batch them. It's sort of, this is the happy medium between uploading vectors one by one and, worrying about running into that 2 megabyte limit. And is what they said is sort of the optimal number. So that's why we have it set up here. So it looks like a lot at first glance here, but really the things to consider here is what we're going to be passing into our vector. So we're going to be creating an ID. We're going to be passing in our actual vector. So this is going to be the numerical representation of that piece of text that we get from OpenAI. And then we're going to create our metadata. So we'll have the location of where it shows in the text file. In this case, we're going to have the page content that we're going to pass in. So instead of referencing it within a separate SQL database, like you potentially could with a Pinecone setup, we're going to just have that text embedded in the metadata as well. And then finally, we're going to have the text path where you can sort of use this if you want. Say you want to have a reference where you could say, these answers came from these files or websites or whatever. So then we're just going to actually loop through and batch them, and then we're going to upsert them. This is going to be how we actually get them into Pinecone. So once we've done that, we're going to say, okay, Pinecone index is updated with this many chunks. And that's it for this file. All right, in this last file, what we're going to be doing is we're going to be querying the Pinecone index, and then we're going to be taking those top results and then passing it into an LLM with our question. So the first thing that we're going to do is we're going to require a handful of things. So we're going to require the OpenAI embeddings endpoint. So this is going to be what we use to not encode, but embed rather our question. So that's going to be essentially what Pinecone runs through on the back end. It's going to say, okay, we have this vector, now run through the index and see which ones have the highest relatedness between them. So once we've done that, we're going to import OpenAI. This is going to be how we actually use the LLM that we'd like. And then we're going to load QA stuff chain. So this is one of the chains available in Langchain. There's a handful of them. I expect some of these to change over time and more to be added. But essentially what this is doing is taking the context of our results and the question, and then having that question be asked on the context. So there's some sort of nuances there within all the different chains that do a similar thing. So you can play around with these if you like. You can go to their documentation and look at chains. And then we're simply going to require document from Langchain. So here, similar to our other files, we're going to export const function name, take in our parameters. Then we're going to log out that we're within this function and sort of walk through the steps of what we're doing like we've done in the other files. So we're going to retrieve the Pinecone index like we did in the other files. Then we're going to query the OpenAI embeddings endpoint, and we're going to pass it in the question. So once we've done that, we're going to specify how our query for the Pinecone index. So in this one, the top K, that's the number of results that we want to have returned. If there's less than 10, say if there's not that many matches, it will just return less than 10. It could return 0, obviously. If say you query something to do with like what's the best MacBook in Romeo and Juliet and the Great Gatsby, it should return you 0. Then we're going to pass in our vector here. Then we're going to ask it to return that metadata. So like we had in our update Pinecone, so within the metadata, we have some things that we could use like that, the reference of where it came from. But in this case, we're just going to be using the actual text content that we included in our metadata. So then we're going to log out if it's found matches. So we're going to say, okay, we found 10 matches, let's say. And then we're going to say, okay, now we're asking our question, and just log out that question, whatever we had in that main file. So once we've done that, we're going to go ahead and set up two separate conditions. So if there's matches, go ahead, set up that instance of OpenAI, load in the chain and pass in our LLM into the chain. And then we're going to extract and concatenate our 10 results, or however many get returned. Then we're going to execute the chain. So we're going to pass in our question and then our input documents here. And then finally, we're going to log out the answer if we have one. Otherwise, we'll say, since there are no matches, GPT-3 will not be queried. So you can use GPT-4 if you want. I'm using GPT-3 for this just because I found it has worked well enough, and the cost is considerably cheaper. But feel free to use whatever you'd like. So that's pretty much it. So now we should be able to save and run the application. So if I say node and let it run, we can see, okay, it's checking, it's splitting it up. So since mine's already been embedded and whatnot, I'm just going to go in and show you how you could potentially just play around with this or set up separate conditions if you'd like, not to have it updated. You could maybe have like a manifest or a more sophisticated way of checking whether those files have already been uploaded into Pinecone. But just to show you how this works, so if I just turn off that update Pinecone, which is arguably the most involved and function that will take the most time, especially if you have longer documents. And if I just go ahead and run it, we'll see that the Pinecone instance has been created, but then it will essentially just go ahead and ask our result. So it will embed that question, and then once it's embedded that question, it will go ahead and give us the result. So it's asking the question we see here. It found 10 matches. Now we're just waiting for GPT-3 to return the results, and it should only take a moment here. So we see Mr. Gatsby is etc., etc. So that's pretty much it for this video. If you found this useful, please like, comment, share, and subscribe. I have a lot more Langchain content and things around this sort of AI boom that we see occurring right now coming out. So yeah, if you found this useful or like this content, I look forward to seeing you in the next one. So until then.